So I wanted to show you guys the shortcut method that is very useful, especially when we have our online classes that we have access to this Excel spreadsheet that I was able to create that allows you to, not go through all the mind-numbing experience of trying to plug in and do all these equations by hand. You could actually plug it into this Excel spreadsheet and get your output really quick, right? So if you can imagine, if you were taking this class in the classroom before the pandemic, right? We have you're basically not able to use this Excel spreadsheet, but now that we are kind of learning from home, we can most definitely use this Excel spreadsheet even during exams. So keep in mind that you have access to this, and if you want to use it, you can feel free to use it. But you just got to make sure you are entering the right things into it. It's not just, even though it looks like plug and chug, you just got to be careful about that. All right. So for this this example of the this door that's going to move up and down, we can go ahead and identify that it's a slider crank. We already said it's an offset slider crank. Right. We got to be careful though, because you have to make sure you match up the problem picture with the general picture that's given in the Excel spreadsheet. Right, so if you can imagine rotating the the picture of the problem, you have to rotate it to try to match up with the general picture. I'm hoping you could see that the door, if you rotate this picture, let's see, counterclockwise, 90 degrees, and I'm not going to do that right here, right? But if you rotate it 90 degrees, you would see that the slider is above the pivot point, which is not the case in the general picture, which means you're going to need a negative L1, right? And that would be a distance of 9 inches, so I'm going to put a negative 9 in my spreadsheet, right? I'm going to go to L2, which should be the easy stuff, 8. L3 is 15, if you see from the problem picture, right? Theta 2, you got to be careful though. Theta 2 is with respect to a horizontal line that is parallel to the line that the slider is traveling. Right? So if you can imagine that there's the problem picture is a vertical line that's parallel to a line that the door would travel, right? Along, I should say. All right, so that would actually be, in the beginning we had a 10-degree angle right here. So I actually have to add 10 plus 90 degrees to give me that true theta 2. So that means that would be 100 degrees. Right? We don't have to worry about an omega 2 or an alpha 2. We are not there yet, so we will bypass those guys. Right? So just like magic, right? When you go ahead and enter in L1, L2, L3, and theta 2, your output, right? As you can see, we want basically L4, 13.568, and look at that, you have a 13.569 right there, right? So that was the before number, right? And then this says it rotates to a 40-degree angle, right? This is the after. Actually, not do that. All right, so it's a 40-degree angle. That means we have 40 plus 90 degrees. That would be a 130-degree angle, right? And then as soon as you input that new angle, you get a 9.58, and there's 9.58 right there. All right, so you could see how much time you just saved yourself, right? Because this wasn't an easy one to derive from the trig and geometry, right? You saved yourself a lot of time by entering in the L values and the theta 2 to go ahead and get your before and after L4s. That's going to help you solve this thing, all right? So most definitely use the Excel spreadsheet to your advantage, and I'm just going to let you know right now, right, and many other times, that you can use this, but just got to make sure you know how to use it. Okay? Let's keep on going down our list here, and here's another one, right, where we can go ahead and match up and see if we can do this relatively quickly. All right. So this was another slider crank, which was actually pretty easy because this was an inline slider crank, so that means L1 is 0. Let's go to 2, which would be 50, and L3 would be 40, if you could see it. All right, and the original angle that it starts at is a 30-degree angle. You see it's going the opposite direction, right? But that's not a big concern, right? Because you can just imagine this was flipped the other way, right? It's not a big deal. So as soon as we do that, we get an L4 of 74.526. All right, we see a 74.52. Don't worry too much about farther down the line decimal points. We're close enough, okay? And then it says that it rotates downward 15 degrees, so that makes a theta 2 prime of 15. And as soon as we enter that in, we see 86.145, and you see 86.14. So once again, it works as it should. All right, you can see how you save yourself a lot of time by not having to manually enter in, or I should say, do these equations here, even though they're pretty easy. You can most definitely save yourself a lot of time by using the spreadsheet. Since I can't help myself, we'll keep on doing it. All right, where we see this other example that we talked about. All right, and everything's already lined up for us, right, with the L1 and the theta 2s and all that good stuff. Right, so we'll just plug everything in. Here's L1 is 1, L2 is 5, L3 is 4, theta 2 to start off with is 10, and we see the 8.46, and there's 8.46 right there. And the only other change we need to make is a theta 2 prime of a 25 degrees. And we'll go to the next slide, and we should see 7.04, and there's 7.04 right there. All right, so everything matches up. Get things done very quickly. And then, not to be outdone, we have the 4-bar linkage, and I also have it right here. All right, so the 4-bar linkage we could also do. All right, and we've already identified all the L's and the theta 2, so we'll just go right down the line here. All right, so 25 and a 12 and a 20 and a 15. And then theta 2 starts off at 90 degrees. Don't worry about omega 2, don't worry about alpha 2. Alright, and we're trying to find theta 3. That's the main one. Theta 3, 6.03 from my Excel spreadsheet. And that's what we got right here. After all this plugging and chugging into the big equations, it takes a lot of time to do that, but we see a 6.03 matching up with that. And then theta 2 prime is a 60 degrees. Change that over, and we'll go to the next slide here, and we get a theta 3 of a 13.298, 13.3 degrees, matches up very nicely. So as long as you know what you're trying to look for, and you can even see theta 4 is already calculated as well. If you needed any information about that fourth link, you can get it very quickly from the Excel spreadsheet. So please feel free to use it. Know that it's there. It's already in Canvas for you, so you have access to it. It is my gift to you.